Hey guys, welcome back to our YouTube channel. Hope you guys are all staying safe and doing well during this pandemic. And I know this remote learning is new for you guys. It's new for us too. And I hope we can all learn a thing or two from this whole experience. Alright, so this lesson will be about measuring electricity. And the learning intention for today, let's take a minute to write these down in our exercise books, is to understand how and why we measure electricity using different tools. And by the end of this lesson, we should all be able to describe an electric current and how it is measured, be able to describe voltage and how it is measured, and finally describe resistance and how it is measured. Alright, so let's start with why we need to measure electricity. Alright, so the first one is safety. We don't want an incident where there's too much electricity where it might put us or others at risk of electrical shock, like in this bottom left image here. And our second reason is we need enough electricity for the equipment to work. So we need like in this picture, we need enough electricity for the light bulb to light up and these electric drills to actually work. If there's no electricity, they won't actually function like they should. So the first important term we need to know in regards to electricity is current. An electric current is formed whenever charge flows from one spot to the other. And there's two important types of current that we need to know. One is known as DC and the other is known as AC. You might have seen these terms before. DC stands for direct current, and it means the current flows along the wire in the same direction. And alternating current, the current flows back and forth along the wire. So if you look at the image on the top right, you can see these electrons moving in the same direction for DC. They're just moving to the right. And AC, it goes to the right and then to the left, it just swaps in between and interchanges. Alright, so electric current is measured using an ammeter. An ammeter looks like one of these. Hopefully we will be using one of these in the future if we're back in term 2. If not, we might not be able to have a chance to use those. And the unit used to measure current is ampere, and the symbol is A, and it is often shortened or called amps. Yep, the next important term we need to know is voltage. So voltage is a measure of the difference in electrical energy between 2 points on a circuit. The bigger the difference, the higher the voltage. Voltage is measured using a voltmeter. That's on the top right here. Looks very similar to an ammeter, but notice it has a V this time on the face. And the unit used to measure voltage is volts in the symbol V. And the third main term we need to know is resistance. So resistance is the measure of how hard it is for electricity to move through a circuit. A high resistance means it is difficult for electrons to move, and a low resistance means it is easy for the electrons to move. And resistance is measured using the unit ohm, and this symbol is often used. It's the Greek symbol for omega. And if you notice this image on the bottom right, it is a multimeter. It can be used to measure resistance, voltage, it's got the image here as well, and it can also be used to measure current. And if you had a question about what a circuit is, it's just one of these here. It's just where electricity flows around. Yep, so they're the main things you need to know for this lesson. Now I'll go in a bit more detail with the key main terms. So this one is in relation to voltage. So in Australia, PowerPoint supply 240 volts to the device plugged in. So that's the wall socket here. So everything that's plugged in will get 240 volts by default. In South Korea, that's 220 volts. In every country is a bit different, but in Australia, it will be 240. So if you think about it, not all electric appliances need the same amount of electricity. A laptop will need something different, a mobile phone will need something different, and a fridge might need a bit more, and ovens as well. So sometimes a transformer is used to reduce the voltage from a power point to the required voltage. So for example, mobile phones need 5 to 6 volts, digital cameras often need 6.4 volts, and laptops need 19 volts. So we have a transformer like this brick here. If you look at your laptop charger, there's this square brick kind of looking thing that's known as a transformer. That drops it down the voltage from 240 volts to whatever is required for your device, so that it won't overpower your device and it will provide the correct amount of voltage that is needed. Alright, so that was in relation to how we control voltage in a real life circumstance. So let's have a look at how we control resistance this time. So resistance of a wire depends on the type of material the wire is made of. So each metal has a different resistance, and depending on the type of material or metal that you make the wire out of, the electrons or electricity will be able to flow easier or more difficultly. The length of the wire is also a key factor. So if the wire is 2 times longer, it means it will have 2 times the resistance, making it harder for the electrons to pass through. And also the thickness of the wire, the thicker the wire it is, the harder it is for electrons to pass through. So it means it will have a higher resistance. So other than changing the length of the wire, the thickness of the wire, or what the material is, there's also another way of controlling resistance, and this is done by using resistors. So these are components that have a known resistance and are used to restrict the current flowing through them and the rest of the circuit. So they look like this on the bottom left over here, sorry about that. Yep. And we also have something called variable resistors, which allow you to change the resistance to control the voltage and current in a circle. This is often used to control the brightness of light globes, control the volume of speakers, and the speed of air conditioners and car windscreen wipers. So variable resistance, some images are down here, and once again they're just another way to control the resistance in an electrical circuit. Alright, we're almost done now. We're on our final slide. We just need to learn about what conductors and insulators are, as they are also a key component of electrical current. So conductors mean that an electric current will easily pass through them. Metals are conductors, and some metals are better conductors than others. And this all depends on the resistance of the object, and this is a key thing to keep in mind. Insulators are materials that have such a high resistance that they block the electric current completely. Some examples of these are rubber, plastics, wood, and glass. And because of this, electrical wires are usually wrapped in plastic to insulate them from the surroundings. This is important so when we grab the wire or pick up the wire or try to plug it in, we don't actually get electrocuted. And this rubber or plastic coating is protecting us from that. Alright, so that brings us to the end of the lesson. Once again, thank you for watching this video and tuning into our lesson. Just refer to our lesson plan on Compass to what to do next, and yeah, we'll see you back in the next lesson. Have a good one.
Boom! 2 + 2 is 4, -1, that's 3, quick maths.